this thing that I showed so far doesn't really help you in doing anything better. So it's only just the table rewritten in a different form. However, let's see how we can actually use K-maps to simplify things. So let's start with this one. F is A plus BC plus D bar. Let's see how this thing can be represented in a table. So remember, this function is having 4 variables, namely A, B, C and D, and if I don't mention explicitly, we will keep the order always in increasing alphabetical order, A, B, C, D, X, Y, Z and so on. In this case, we will assume that the function is written as A, B, C, D. I am going to take A, B along the rows and C, D along the columns. So you have A, B, the 4 possible values, C, D with the 4 possible values, with this little twist. We go 0, 0, 0, 1, 1, 1 and 1, 0, similarly 0, 0, 0, 1, 1, 1 and 1, 0 here. Now let's see these 3 terms. So like we did with the truth table in previous module, I am going to go and fill up this K-map table with 1s and 0s. So the first term is A, right? So if A is 1, no matter what B, C and D are, F will become 1, and to capture that, right, so this is a place where A is 1. You can see that AB, you put 1, 1 here and 1, 0 here. So this corresponds to A equals 1 because that is a row where A is 1, and so are all these entries. If I look at all the entries here, they all correspond to A being 1. So B is of course taking 1 or 0, we do not care about that. So if A is 1, all these terms, right, correspond to the min term where A is 1. So all these are the min terms where A is 1. Finally, then let's look at BC. Let's find out all the min terms which correspond to B equal to 1 and C equal to 1. Right. So if you go and look at this column here, so B is 1 and C is 1. So this is a min term which corresponds to B equal to 1 and C equal to 1. But that is not the only place. All these 4 cells correspond to B equal to 1 and C equal to 1. So you go and look at this. This is a row in which, so these are the rows in which B is 1. These are the columns in which C is 1. So the intersection of that is these 4 cells. So these 4 cells correspond to the fact that B and C are both 1. Finally, let's look at D bar. So if D is 0, F should be 1, right. So wherever D is 0, we are going to mark, so we need a 1 there. So let's see. So if I look at this column here, we know that it's CD, where C corresponds to 0 and D corresponds to 0. So this must have a D bar, and so will this and this entry, because all of that corresponds to D being 0. Similarly, if I go and look at the last column, this also corresponds to D equal to 0. So this corresponds to C equal to 1 and D equal to 0. We don't care about the value of C when we look at this term here. So all those entries also become, they are all corresponding to the fact that D should be 0. Now wherever you see something like this, so this is true when A is true, this is true when either A is true or BC is true, this is true only when BC is true, this is true only when D is 0 and so on. So wherever you have some entry, you make all of them once, because that is what the truth table tells us. You can see that, right. So in this, for example in this cell, A is 0, so this is 0, B and C are both 0, so this term is also 0. However, if D is 0, this cell should get a 1. So this is having only the information that D bar should be 1 for this cell to become 1, and in this specific case D bar is actually 1. So wherever we have some entry, we make all of them once. We don't need the sum terms we don't need the product terms anymore, we can drop it. All the terms that are not there, they become zeros. So these 3 entries are zeros. So if I go and write the truth table for this function, it will have 2 power 4 or 16 rows. Among the 16 rows, 13 rows will have a 1, and the rows corresponding to these 3 min terms will have a 0. You try it out. So I put it in the K-maps table, you go and put it in a regular truth table where you have 16 different rows with 4 combinations, and you will notice that min term 1, min term 3 and min term 5 will be zeros if you expand this function. Alright, so you go and try that out yourself. So let's see how K-map is drawn. We start with, So in this example, A, B and C, D are switched around, the same function, but A, B and C, D are switched around. So first A is true for these two columns, then BC is true for these 4 cells, and D bar is true for these 2 rows. And we can do the same thing that we did before. Wherever you have an entry, you put a 1, and wherever there are no entries, you put a 0. This is also a valid K-map. So this is essentially a different way of holding the same truth table. So far what we have is the truth tables and K-maps are not different things. They capture the same functionality, except that the truth table will have a single vector for the column. So you will have one output vector, which is the last column. However, in a K-map, the 1s and 0s are actually embedded inside either a square or a rectangle or something like this. So in this case, we have to pick the ordering of the inputs, and based on that we put the min terms correspondingly. Let us look at another example here. WZ bar plus XY bar plus X bar. Let us say that is the thing that we want to capture. So now let us go and see where WZ bar, what are the cells that correspond to WZ bar. We want W to be on and Z to be off, which means we have to look at the rows where W is on. So which are the rows where W is on? These are the 2 rows where W is on. But we also want Z to be 0 or Z to be off. So these are the 2 columns where Z is off. So the WZ bar will correspond to the intersection of the condition where W is on, which are these 2 rows, and Z is off, which are this column and the last column. So those are the 4 terms that correspond to WZ bar. Now let us look at the middle term XY bar. For XY bar, we want X to be on and Y bar to be on, or X to be on and Y to be off. Where is X on? X is on in these 2 rows in the middle, right? So, and we take the intersection with wherever Y is off, that is this column and this column. So the intersection of these 2 rows and these 2 columns give me these 4 cells, these cells here. That is my XY bar. Finally, X bar is these 2 rows. So wherever you have any such term, right, you started with a blank one, wherever you have such a term, you put 1s, and you can get rid of the actual terms that gave you that, and wherever you do not have them, you can put 0s. Okay.